Imagine for a second just looking at your enterprise cloud bill at the end of the month, right?
Oh, that is always a scary moment.
It really is. And imagine realizing you have been paying thousands of dollars for this massive high-performance database and a whole fleet of application servers that literally did nothing all month.
Just sitting there totally idle.
Exactly, just sitting there. They were not processing orders, they were not compiling code, they were just running with the meter ticking, all because someone missed a single line of JSON configuration.
Or they just did not understand the hypervisor boundaries of their cloud environment.
Right. And it happens every single day. So today we are doing a deep dive into SAP Business Technology Platform, or BTP.
And we are getting really into the weeds today.
We absolutely are. We are moving way past the marketing brochures here.
Yeah.
We're looking at this platform for what it truly is, which is, it is basically a hyper-advanced global operating system for enterprise business.
It is an operating system in the truest sense. It is just scaled out across these distributed hyperscaler data centers. And when you look at it through that lens, the stakes completely change. So welcome to the deep dive. Our mission today is to completely tear down the runtime environments of SAP BTP.
No high-level fluff allowed today.
None at all. We have this massive stack of SAP architectural documentation, system operations guides, and deployment parameters right in front of us.
We are going to architect actionable solutions.
Exactly. Focusing specifically on Cloud Foundry, Kyma, and the ABAP environment.
Because if you are an enterprise architect or a lead developer listening to this, understanding exactly why you are deploying a specific runtime is crucial.
Yeah, the why and the how.
Right. How to surgically configure its quotas, its namespaces, its JSON parameters. That is not just a nice-to-have skill anymore.
No, it is the absolute foundational requirement for modern SAP cloud architecture.
Because if you get this wrong, you are basically paving the road for runaway costs.
Runaway costs, catastrophic security vulnerabilities, and just, architectural dead ends that will take months to untangle.
So let us start at the very bottom of the stack.
Right, the core architectural building blocks.
The SAP documentation gives us a highly specific taxonomy here. There are 4 terms we need to lock down: environment, runtime, instance, and quota.
And these are not just vocabulary words, right? They represent strict boundaries of execution in the cloud. Let us unpack the mechanics of what these actually are in the data center.
Right, because if we do not lock these definitions down right now, everything else we discuss today is just going to fall apart.
Totally.
So let us start with the big container, the environment. In SAP BTP, the environment is basically your platform as a service offering.
It is the overarching abstraction layer.
Yeah, so when you provision an environment, you are not just getting a bare server, you are getting the entire management plane.
The API gateways, the routing layers.
Right, and the underlying orchestrator that will eventually manage your actual code execution. So it is the passive foundation.
And sitting immediately underneath that environment abstraction, you have the runtime.
Okay, so what is the runtime mechanically?
The runtime is the actual execution arena. It is the engine that provides the physical compute resources, the memory space, and the language-specific settings for your applications.
So the environment governs the space, but the runtime executes the code within it.
Exactly. Which naturally leads us to the third term, the instance.
I always think of a service instance as like the active, materialized version of a capability.
Yeah, that is a great way to put it.
It is what actually runs inside that runtime, living right alongside your custom applications. So if you need a PostgreSQL database, you instantiate it.
Or an event mesh, or an authorization trust management service.
You instantiate it, and it becomes a living process inside those runtime boundaries.
Precisely. And governing all of this, acting as the absolute physical boundary, is the quota.
And a quota is not just a soft suggestion, is it?
Oh, absolutely not. It is a hard numeric limit enforced by the BTP control plane. An environment defines quotas for its runtimes based on the global entitlements that your enterprise actually purchased.
So the quota literally dictates how much memory or how many routes or compute units your runtimes are allowed to physically spin up.
Right, before the hypervisor simply says no and blocks any further provisioning.
Okay, I want to challenge SAP's fundamental architecture here for a second, though.
Before it.
If an environment is basically this highly structured, fenced-in yard, and a runtime is the engine executing inside that yard,
Yeah.
why on earth do we need completely different types of yards? Why do we have a Cloud Foundry yard and a Kyma yard and an ABAP yard?
It is a totally fair question.
From an engineering perspective, would it not be vastly more efficient to just build one universal, unified BTP environment that handles every single workload.
It is a debate architects have constantly, honestly. But if you look at the actual mechanics of how these workloads process data, a universal environment is a logistical nightmare.
Really? Why?
It comes down to the fundamental difference between architectures that are cloud native and architectures that are cloud enabled.
Okay, explain that mechanical difference to us, because those terms get thrown around like buzzwords all the time.
Oh, constantly.
But in BTP, they dictate your entire deployment strategy, right?
They absolutely do. So let us look at Cloud Foundry and Kyma first. These are cloud-native runtime environments,
Meaning they were built for the cloud from day one.
engineered from the very first line of code to exist in a highly distributed, ephemeral cloud infrastructure. They are designed to be these polyglot playgrounds.
Polyglot meaning multiple programming languages.
Right. You can throw a Node.js microservice, a Python data model, and a Java Spring Boot application all into them, and the orchestrator knows exactly how to containerize, scale, and route traffic between them.
Because they assume the underlying hardware will eventually fail.
Exactly. They handle state and persistence knowing that a server could die at any second.
Right, they're built for stateless scalability. If a node dies, the environment just spins the container up somewhere else in the cluster.
Exactly. But then you look at ABAP.
Ah, ABAP.
Right. The ABAP environment is what SAP calls cloud-enabled. ABAP was not born in the cloud.
Not even close.
It has decades of legacy tied to the NetWeaver kernel, tightly coupled processing logic, and very specific stateful requirements for how it interacts with the SAP Agena database.
So you cannot just take an ABP on work process and run it natively inside a standard Kubernetes pod.
Not without massive architectural bridging.
Yeah.
So the ABP environment is this highly specialized runtime, purpose-built solely to bring traditional SAP custom code and S/4HANA extensions into the cloud era.
It requires a specific execution engine that a generic cloud-native environment just cannot provide on its own.
Right.
That makes a lot of sense. You cannot just drop an engine block designed for a freight train into a sports car chassis and expect it to perform.
That is a great analogy.
And speaking of legacy architectures, the documentation does include a historical artifact we really need to address for a minute.
Oh, I know what you were going to say.
The SAP BTP Neo environment.
Yes, the infamous Neo environment.
For any architects out there dealing with older legacy landscapes, you know Neo. It was the original proprietary SAP PayS environment.
Heavily utilized for HTML5 apps, Java, and the old SAP HAN Extended Application Services, or XS.
Right, but the documentation we are looking at is incredibly explicit about this. Neo is strictly for existing customers.
Correctly.
If you are sitting on Neo today, the architectural directive from SAP is clear. You need to plan your migration to the multi-cloud foundation, which means Cloud Foundry or Kyma.
SAP's innovation pipeline is entirely focused on multi-cloud now. Neo is the past. Multi-cloud architecture gives you the flexibility to deploy across AWS, Azure, Google Cloud, and Alibaba.
And this actually brings up a really subtle but highly indicative UI detail in the BTP cockpit.
Oh, I love this UI detail.
The next time you log into your subaccount overview, you need to look at how the control plane displays these environments. It perfectly mirrors the cloud-native versus cloud-enabled architectural split we just talked about.
Right. When you look at the subaccount overview, Cloud Foundry and Kyma appear in their own dedicated, distinct tabs right at the top level of the UI.
They are treated as foundational pillars of the subaccount.
Exactly. But the ABAP environment, there is no tab for it.
Zero. It is not there.
Because it is not a foundational PyS environment in the same way. It is handled by the BTP controller as a standard service instance.
Meaning it only shows up in your entitlements list and your instances view.
Yeah. It is a brilliant UI decision that forces you to realize ABAP is a workload running on top of your cloud infrastructure, not the infrastructure itself.
All right, so let us get into the weeds on the first of these foundational pillars. Let us look at the mechanics of the Cloud Foundry environment.
Cloud Foundry is basically your PyS workhorse.
It supports multiple runtimes, and it handles various build packs, right?
Right, and build packs are how it automatically detects your code language and compiles it into a runnable container without you doing it manually.
And it manages its resources through an organizational structure built around orgs and spaces.
And that organizational structure, it is rigid for a very specific reason. The BTP documentation lays out a very strict topological relationship here.
Okay, what is the rule?
A single subaccount contains exactly one Cloud Foundry org.
1-to-1.
Exactly. There is a rigid one-to-one mapping between the subaccount boundary and the Cloud Foundry organization boundary.
Okay, I have to push back heavily here.
Let's hear it.
The documentation emphasizes this one-to-one mapping, and because of it, SAP heavily recommends following a stage development process.
Right, dividing subaccounts by stages.
Yeah, they want you dividing your subaccounts, and therefore your orgs, by rigid stages like dev, test, and prod. But let us look at the reality of modern software engineering right now.
It is fast.
We are in an era of rapid CI/CD pipelines, ephemeral environments, dynamic testing. Is this rigid, monolithic dev, test, prod org structure not incredibly outdated?
From a development point of view, sure.
Does it not create massive administrative overhead for an enterprise that just wants to, spin up a feature branch, test it, and tear it back down?
It is a phenomenal point, and it is the exact friction point between modern agile development and enterprise governance.
Because it just feels slow.
Yes, from a pure developer velocity standpoint, it feels rigid. You want to spin up infrastructure on the fly. But you have to view this through the lens of enterprise risk, data sovereignty, and blast radius.
Blast radius is the key word there.
Absolutely.
Oh.
When you create a Cloud Foundry org, you are establishing a hard boundary at the hypervisor network level.
A hard boundary meaning traffic cannot traverse between orgs unless explicitly routed over the public internet or through a dedicated transit gateway.
Correct. The isolation is absolute. Think about it. In a massive enterprise, your production org contains live customer data, financial records, PII.
Real sensitive stuff.
Yeah. And your dev org contains dummy data, experimental code, and often less stringent access control so developers can actually debug things.
Right.
If you mix dev and prod workloads in the exact same org and simply rely on software-defined routing to keep them separate, you are asking for trouble.
Because a single misconfigured network policy could ruin everything.
Exactly. A runaway memory leak in a dev microservice could literally starve your production database of compute resources or expose live data.
Ah, okay.
The overhead of managing separate dev, test, and prod subaccounts is basically the insurance premium you pay to guarantee that a junior developer's infinite loop in a sandbox does not take down your global supply chain routing system.
Okay, I concede the blast radius argument. Security and resource isolation have to trump pure developer convenience at the enterprise level.
They really do.
So the org is our massive stage-specific container. But inside that org, we partition the resources using spaces.
Yes.
And the texts continually emphasize that spaces are the ultimate granular control unit in Cloud Foundry.
They are the granular control unit because that is where the user count and authentication service, the UAA, actually maps roles to resources.
Okay.
Spaces run inside orgs, and they are the entities that provide the actual physical RAM and CPU allocations for your apps and service instances.
So why does this matter so much for administration?
Because access, authorizations, and quota limits are enforced at the space level. The space is the smallest definable account management entity.
Give me a practical enterprise scenario where the space-level isolation is critical.
Sure. Let us say you have an HR development team and a finance development team, and they are operating inside your single dev org.
Okay, 2 teams, 1 org.
You do not want them sharing a space. If finance deploys a massive, memory-heavy data extraction application that unexpectedly spikes CPU usage, and they share a space with HR.
The HR apps suffer.
Exactly. The HR team's lightweight payroll extension microservices might suddenly start failing due to resource starvation.
Right.
By assigning finance their own space and HR their own space, you enforce a hard quota limit on both. Finance can only consume the RAM allocated to their space.
If they hit the ceiling, their apps crash, but HR's apps continue running perfectly fine.
Precisely.
Which brings us to a massive action item for anyone setting this up, and that is naming conventions.
Oh, this is so important.
This sounds trivial, right? But in BTP, it is an architectural landmine. You cannot just name these entities test space 1 and my org and call it a day.
Please do not do that.
The BTP architecture heavily relies on string matching for back-end routing. The documentation provides a very explicit naming template, particularly for your org name.
Yes.
The rule is use your subaccount subdomain.
Let us walk through the mechanics of why that rule exists. Give me a typical enterprise subdomain.
All right, let us say we are a global company and we have a European human capital management development environment. Our subaccount subdomain might be btpops uacmdev.
Okay, so SAP dictates that this exact string should be used as the Cloud Foundry org name.
Why does it have to be exact?
Well, here is the vital architectural warning. Keep those org names simple. No special characters and absolutely no spaces.
No spaces ever.
Never. The reason is not just aesthetic. Deep
Yeah.
within the BTP ecosystem, other enterprise services utilize that exact org name string to programmatically construct API endpoints and routing tables.
Ah, like the SAP Cloud Transport Management Service, or CTMS.
Exactly. CTMS is the engine that moves your code from dev to test to prod. When you configure CTMS transport nodes and destinations, the destination service resolves the routing path by looking for that org name string,
So if your org name is full of spaces or ampersands.
or bizarre character encodings, the destination service's backend parser will just fail to resolve the URL endpoint.
Wow.
Your automated deployment pipelines will simply fail to reach the target environment, throwing these opaque 404 errors.
Yeah.
And your DevOps team will spend days trying to debug a network routing issue.
When the reality is you just use an invalid character in your org name.
Exactly.
It is always DNS or a bad string parse every time. Okay, so that is the org. What about naming the space itself?
For space naming, the principle is brevity and context. Do not repeat the account structure information.
So I should not name it something like EUHCM dev payroll space.
Definitely not. Why? Because from an API perspective, you are always querying the space through the context of the org anyway. The hierarchical path is already established.
Right, the system already knows it is in dev.
Exactly.
Yeah.
Instead, name the space purely by its business purpose and keep that string identical across your staged landscape.
So if it is a space for payroll extensions, just call it payroll X.
Yes.
And you have a payroll X space in the dev org, the test org, and the prod org.
Right. And that makes automated deployment scripts so much cleaner because the destination space name is a static variable in your CI/CD pipeline. You only change the target org variable depending on the deployment stage.
That makes perfect sense. It enables pipeline automation. Now let us talk about one of the most frustrating mechanical traps in Cloud Foundry resource management.
Oh, the quota trap.
Yes, we mentioned quotas acting as the physical boundary for resources. When a platform administrator creates their very first space in a brand new Cloud Foundry org, the orchestrator does something highly unintuitive by default.
It really is unintuitive.
It has burned so many people. By default, Cloud Foundry assigns 100% of the available org quota to that very first space.
It literally grabs every single megabyte of RAM, every available route, and every service instance entitlement.
Mechanically, the system is assuming that if you only have one space, you want all resources available to it, right?
Right? But in an enterprise, you are almost always setting up multiple spaces for different teams.
Which means when the administrator attempts to create a second space for a different team, the BTP control plan throws an error stating there are 0 resources left to allocate.
Exactly. And the fix is a manual administrative step. Before you can create space B, you must manually enter the quota management screen, edit the quota plan assigned to space A, and mathematically reduce its memory and instance limits.
You literally have to shrink the pie slice to free up room for the new spaces.
Yes. And while you are in those quota configuration screens, you will encounter another classic trap.
The infinite quota illusion.
Exactly. The documentation notes a configuration tip. It says if you enter -1, so -1, into a quota parameter field, the system interprets that as unlimited.
It removes the specific numeric cap for that parameter within the space.
But let us look at the mathematical reality of -1. You cannot actually have infinite resources in a data center.
Right. This is a crucial reality check for architects. You can type -1 into the RAM allocation field, but your space does not suddenly magically have infinite memory.
Precisely. The -1 simply tells the space orchestrator, hey, stop policing my memory consumption at the space boundary and just draw it directly from the total org memory pool.
But the hard physical limit of the total org entitlement still exists.
It absolutely does. If the org has 64 gigabytes of RAM total and your space is set to -1, your apps can consume up to 64 gigabytes. But at that point, the entire org crashes.
Wow.
The only resource in Cloud Foundry that is truly unlimited in a technical sense is the number of application instances.
Meaning you can spin up 1,000,000 tiny applications as long as their combined memory footprint does not exceed the physical RAM limit of the org.
Exactly. The orchestrator does not care how many logical app processes you define, but the hypervisor cares deeply about the physical RAM they consume.
So for the engineers listening, here is an actionable sequence, a hands-on exercise straight from the deployment guide.
Okay, let us go through it.
To get Cloud Foundry running, you follow 3 distinct mechanical steps. Task 1, add a service plan for the Cloud Foundry environment at the global account level.
Right.
Task 2, enable the environment inside your specific subaccount. And Task 3, create a service instance within a space.
And a perfect foundational instance to start with is the HTML5 application repository service, specifically utilizing the app host plan.
This acts as the centralized storage for your UI5 applications, right?
Yes, exactly.
And when you are provisioning that instance, remember our rule about string parsing? Instance names must be strictly CLI friendly.
Maximum 32 characters, alphanumeric only, with periods, underscores, and hyphens permitted.
Absolutely 0 spaces.
None. Because if you include a space in the instance name, the YAML parser used by the Cloud Foundry command line interface will fail to interpret the string.
The arguments will shift, and your deployment automation will violently crash.
It is a microscopic detail that prevents massive headaches.
So we have established the pious foundation with Cloud Foundry.
We have.
But as enterprise applications evolve, developers often outgrow the constraints of traditional pies. When a team brings in a massive, highly complex web of containerized microservices that need intricate traffic routing, mutual TLS, and granular horizontal pod autoscaling,
Cloud Foundry's spaces start to feel very restrictive,
the abstraction is just too high at that point.
which means we need to step down a layer and get closer to the orchestration metal. We are leaving Cloud Foundry and diving into the Kyma runtime.
This is SAP's Kubernetes powerhouse.
Kyma represents a complete paradigm shift in how BTP handles execution. The Kyma runtime is essentially a fully managed Kubernetes cluster based on the open-source Kyma project.
And its architectural mandate is to allow developers to build cloud-native serverless functions, deploy complex containerized microservices, and seamlessly integrate them with SAP systems.
Right. And because it is Kubernetes under the hood, we completely lose the concepts of orgs and spaces.
Okay, so what is the organizational topology in Kyma?
Kyma relies on standard Kubernetes primitives. The overarching boundary is the cluster. And within the cluster, resources and boundaries are partitioned using namespaces.
Let me try to contextualize the difference between a Cloud Foundry space and a Kubernetes namespace, because I think it is a crucial distinction in isolation depth.
It really is. Go for it.
Think of Cloud Foundry like a massive enterprise apartment building. Everyone has a key to their own flat, and those are your spaces.
Okay, I'm with you.
You have your own living area, but you share the plumbing, the HVAC, and the hallways. If a rogue application in someone else's space decides to spike its CPU usage and the orchestrator is not perfectly tuned, it can degrade the performance of the entire building.
Right, the classic noisy neighbor problem.
Exactly.
Yeah.
But Kyma's namespaces operate fundamentally differently because they utilize Kubernetes control plane and data plane isolation mechanisms.
They're different.
Instead of an apartment building, it is like having entirely separate, heavy-duty physical bank vaults within the same facility.
Like that.
Through the use of network policies, subgroups, and resource quotas at the kernel level, the isolation between namespaces is incredibly strict.
It is absolute.
A microservice in namespace A cannot even resolve the DNS of a microservice in namespace B unless an architect explicitly writes a network policy allowing that specific port traffic.
That is exactly how network policies function in Kubernetes, and Kyma enforces that out of the box. It gives platform engineers absolute microscopic control over network flows and resource consumption.
So how do we actually administer this cluster? Cloud Foundry has its CLI and the BTP cockpit. How do we interface with Kyma?
The primary visual interface is the Kyma Dashboard, which is built on an open-source UI framework called Bussola.
Okay, Bussola.
You can access it via the console URL parameter in your BTP cockpit, or directly navigate to dashboard.kyma.cloud.sap.
Right.
But what makes Kyma fascinating is that it is not just a raw, empty Kubernetes cluster.
Because raw Kubernetes is actually incredibly difficult to use for enterprise development.
It is a nightmare to manage from scratch. Kyma comes pre-packaged with a modular ecosystem of vital enterprise tools.
Right, it is a batteries-included approach.
Exactly. But it uses a modular architecture, meaning you can explicitly add or disable these modules based on your architectural needs to free up compute resources.
Give me some examples of these modules.
Well, for example, it includes an API gateway module for exposing and securing your endpoints. It has the SAP BTP operator module for natively managing BTP service bindings directly from within Kubernetes.
Oh, that is useful.
And it has Istio, which acts as a massive service mesh for managing traffic routing, telemetry, and zero-trust security between your pods.
Let us talk about Istio for a second, because that represents a significant architectural trade-off.
It really does.
Istio is incredibly powerful, but it achieves that power by injecting a proxy sidecar container into every single pod in your cluster.
Yes.
That means every time you spin up a microservice, you are also spinning up a proxy. If you have a cluster with thousands of pods, the aggregate memory overhead of those Istio proxies is massive.
It is a huge resource sink.
If your architecture does not actually require complex traffic shaping or mutual TLS between every microservice, disabling the Istio module reclaims a tremendous amount of physical RAM.
RAM that you can redirect to your actual business application.
Yeah.
It is a perfect example of why architects must understand the underlying mechanics. You do not just leave everything turned on by default.
Right.
And speaking of modules, Kyma utilizes a specific lifecycle management approach using release channels.
The documentation mentions a regular channel and a fast channel.
Yes, the regular channel is your stable, default release path for a module. It receives vetted, production-ready updates.
Okay, and the fast channel.
The fast channel gives you early previews of new features before they are pushed to the regular channel. As a cluster administrator, you can configure these channels on a per-module basis.
So you can mix and match them.
Exactly. You could have your API gateway on the regular channel for stability, but put the serverless framework on the fast channel to test out new capabilities.
All right, we need to discuss a critical learner action item right now, and this might be the most important security concept we cover today.
Okay, let us get into it.
When you provision a brand new, completely empty Kyma cluster, how do you mathematically prove to the Kyma dashboard that you are the authorized administrator allowed to manage it?
You establish that trust using a heavily encrypted YAML file called the kubeconfig.
The famous kubeconfig.
You download this kubeconfig.yaml file directly from the SAP BTP cockpit via the designated kubeconfig URL. To connect your empty Bussola dashboard to the cluster, you essentially drag and drop this file into the UI.
And that establishes the secure TLS connection and authenticates your session.
It does.
But we need to stop right here and paint a very vivid picture of what this file actually is, because developers often treat configuration files so carelessly.
We cannot overstate the risk here. The kubeconfig is not a standard configuration document.
No.
It contains the exact internet-facing endpoint of your Kubernetes API server, the cluster's unique cryptographic identifier, and your highly privileged authentication certificates.
If a bad actor intercepts your kubeconfig.yaml file, they do not need your SAP BTP credentials.
They do not need your SSO either.
Right. They completely bypass the BTP control plane and interface directly with your Kubernetes API server.
It is terrifying.
With an administrative kubeconfig, an attacker can execute arbitrary code inside your network, instantly spin up a massive fleet of crypto mining containers that will bill tens of thousands of dollars to your enterprise AWS account by morning.
And systematically wipe every persistent volume containing your customer data. Mishandling this file is literally handing a loaded weapon to the internet.
Do not email this file. Do not commit it to a GitHub repository, public or private. Do not leave it on a shared corporate drive.
It should reside locally, heavily encrypted, or be managed by a secure enterprise secrets vault.
Message received loud and clear. Assuming we have secured our access, let us talk about naming conventions for the Kyma environment to maintain parity with our Cloud Foundry strategy.
For the cluster name, SAP's architectural recommendation is to use your subaccount subdomain, but cleanly omit the company prefix.
So if your global subdomain was Acme Ampaprod, representing Acme Core's America's production environment, your Kyma cluster name should simply be Ampaprod.
Exactly.
And for the Kubernetes namespaces themselves.
Namespaces are fundamentally designed to group related microservices together, and those microservices often span across multiple subaccounts. Therefore, your namespace name should be a shared identifier based on the solution.
Okay, makes sense.
However, a crucial best practice noted in the documentation is to omit stage identifiers like prod in productive environments.
Why is that?
Well, a namespace running your payroll microservices in production should not be called payroll prod. It should just be payroll because the environment context is inherent to the cluster it resides in.
Oh, right. Because the cluster itself is already named prod.
Exactly. Redundancy just makes automation harder.
All right, here are your hands-on execution steps for Kyma. Task 1. Add the Kyma service plan to your global entitlements. Task 2. Enable the runtime and the subaccount.
But before you click that enable button, There is a serious operational reality you need to understand.
Yes, tell them.
When you initiate the Kyma enablement, do not sit there staring at the BTP cockpit expecting a 30-second loading bar.
It takes a while.
The orchestration happening behind the scenes is immense. The BTP controller has to call out to the hyperscaler, say AWS, provision a fleet of EC2 instances, bootstrap the Kubernetes control plane, install the container networking interface, configure the storage drivers, and deploy all the foundational Kyma modules.
So how long does that actually take?
This mechanical process takes between 30 to 60 minutes. Click Enable and go work on another architecture diagram.
Go get a coffee.
A very long coffee.
Once it finally spins up, task 3 is to access the dashboard, create your first namespace, and immediately apply resource quotas and limit ranges to prevent any single microservice from draining the cluster's RAM.
Essential day one tasks.
Now, while that 60-minute provisioning is happening, there is a fascinating, invisible mechanical process occurring in the background that bridges Kyma back to the rest of the SAP ecosystem.
This is one of the most elegant pieces of engineering in BTP. What's fascinating here is Kyma does not exist in a vacuum. It needs to consume standard SAP services like HANA databases or the destination service.
But Kubernetes natively does not know how to talk to BTP.
Right. So when you enable Kyma, an instance of the SAP Service Manager automatically and invisibly spins up in your subaccount. You will see it quietly appear in your instances and subscriptions list.
It acts as an invisible bridge.
Exactly. The SAP Service Manager acts as the central registry. It implements the Open Service Broker API standard. It tracks all the available BTP service brokers and securely maps their endpoints into the Kubernetes cluster.
So what does that mean for the developer?
It allows your developers to use standard Kubernetes manifests to request a BTP service, and the Service Manager seamlessly handles the provisioning and credential binding under the hood. It connects the cloud-native Kubernetes world directly to the enterprise SAP world without manual API integration.
It is brilliant abstraction. Okay, we have covered the PyS foundation with Cloud Foundry and the highly scalable Kubernetes layer with Kyma.
Now for the heavy hitter.
Yes, we must address the massive legacy-heavy elephant in the room. We are stepping into the ABAP environment.
The system internally known at SAP as Steampunk.
I love that code name, Steampunk. The ABAP environment is the bridge for traditional SAP developers.
It really is.
Its core architectural mandate is to allow enterprises to create tightly coupled extensions for products like SAP S/4 HANA Cloud, or to build entirely custom cloud applications, utilizing the decades of AB expertise their development teams already possess.
But we have to return to the crucial architectural dependency we discussed at the very beginning of the show.
Right.
ABAP is cloud-enabled, not cloud-native. The NetWeaver architecture cannot natively interface with AWS or Azure APIs to request bare metal compute or block storage.
It needs help.
It requires an intermediary. It requires the Cloud Foundry environment we dissected earlier to act as its physical foundation.
Let me make sure I understand the mechanics of this, because it sounds wild. You are saying that an entire SAP ABAP system does not run on its own dedicated servers. It actually runs as a massive service instance inside a Cloud Foundry space.
That is exactly how it works.
Wow.
From the perspective of the BTP control plane, a Steampunk system is just a highly complex, very heavy service instance. You must have a Cloud Foundry org and a fully configured space provision first.
Only then can you go to the service marketplace and instantiate the ABAP environment into that space. That blows my mind, but it makes perfect logical sense. Let us get heavily technical on how we actually size this massive instance, because the entitlement documentation is incredibly specific and mathematically strict.
To physically spin up an ABAP system, your enterprise must be entitled to 3 specific service plans.
Okay, list them out.
You need the ABAP Compute Unit Plan, which provides the RAM and CPU for the application servers. You need the HANA Compute Unit Plan, which provides the massive in-memory database resources. And you need the standard runtime plan to conceptually tie the application and database layers together.
And the mathematical sizing rules for these compute units are critical for architects estimating cloud consumption costs. Let us break down the memory equivalents.
Sure.
One ABAP compute unit fundamentally equals 16 gigabytes of application RAM. One ABAP compute unit equals 16 gigabytes of database memory when deployed on Microsoft Azure or Google Cloud Platform. But, and this is a massive architectural anomaly, If you deploy your BTP landscape on Amazon Web Services, one HNA compute unit is strictly defined as 15 gigabytes.
We need to analyze why that anomaly exists and its cascading architectural implications.
Yeah.
This is not a random typo in the documentation.
Right, it is real.
It relates directly to the physical hardware profiles of AWS EC2 instances,
Right.
and how the Nitro hypervisor allocates memory blocks for HADA certification.
Yeah.
SAP had to make a 1 gigabyte concession on AWS to guarantee performance stability.
And a 1 gigabyte difference sounds trivial until you realize how enterprise systems scale.
Oh, it adds up fast.
If you are architecting a massive production environment and you calculate you need 50 HNA compute units on Azure, that gives you 800 gigabytes of database memory.
Right.
On AWS, those same 50 units only yield 750 gigabytes. You just lost 50 gigabytes of critical high-speed and memory processing power.
Which could mean the difference between a sub-second analytical query and a query that just times out. Architects must account for this hardware constraint during the procurement phase.
The math absolutely matters. Now, when you have your entitlements sorted and you are ready to physically provision the ABAP instance, you encounter one of the most powerful automation interfaces in BTP.
You do not just click through a simple UI wizard here.
No. You pass a strictly formatted JSON payload to the BTP controller to define the exact mechanical behavior of the steampunk system.
This is where architects earn their salaries.
I want to treat this section like a cheat sheet for the listener. I will list the JSON parameter and you break down exactly how the cloud controller interprets it.
Let's do it.
Let us start with the most critical security parameter, admin mail.
If you omit the admin mail parameter, the provisioning will fail, or worse, succeed, but leave you entirely locked out. The BTP controller uses the string to automatically generate the initial administrative user in the ABAP system and binds it to your identity provider. It is the key to the castle.
Next is the classic SAP parameter, SAP system name.
This is your standard 3-character alphanumeric system ID, or SID, that every SAP professional knows. It dictates how the system identifies itself on the network. If you leave this parameter blank in the JSON, the cloud controller will just default to H01.
Then we have the physical hardware boundaries, size of runtime, and size of persistence.
These tell the orchestrator how many of those 16 gigabyte blocks to allocate. Size of runtime dictates the number of ABP compute units for the application layer. Size of persistence dictates the HANA compute units for the database.
Now, here is the parameter that completely modernizes ABAP. It is called elastic. You set this as a Boolean, true or false.
The elastic parameter is a triumph of cloud engineering.
Really? How so?
If you set it to true, you are instructing the Cloud Foundry orchestrator to actively monitor the internal wait queues of the SAP kernel dispatcher.
Okay.
If the system is under heavy load and the dialog work processes are exhausted, the orchestrator will dynamically scale out, spinning up additional APP application servers on the fly up to the maximum limit you defined in size for runtime.
And when the load drops?
It automatically scales them back down to a minimum of 1 unit. It brings true cloud scalability to a 30-year-old architecture.
That is incredible. And finally, the storage parameter, size of persistence disk. The documentation notes this defaults to a value of auto.
And auto is highly recommended because HANA is incredibly sensitive to disk space constraints.
It crashes if it runs out of space, right?
Instantly.
Huh?
If left on auto, the BTP controller mathematically calculates your block storage size based on a formula. It sizes the disk dynamically, keeping it bounded between 40 times your persistence units plus 40 and 120 times your persistence units plus 40.
That is a very specific formula.
This algorithmic buffer ensures your HANA database always has enough disk capacity to write save points and merge delta stores without locking up the system.
So the JSON payload executes, the system provisions, and it is running. How do we visually administer this beast?
You need to subscribe to an application called the Web Access for ABAP service. This provisions the administration launchpad, which is your mandatory Fiori interface for managing business users, monitoring internal system health, and configuring communication arrangements for that specific instance.
But the documentation emphasizes another tool entirely for broader management, the landscape portal.
The landscape portal operates at a completely different architectural level. The administration launchpad looks inward at a single ABA system. The landscape portal looks downward, across your entire global account.
So it is a broader view.
It is the central lifecycle management orchestrator for every steampunk system you own.
And there is a critical deployment note here. The landscape portal is not an ABP instance itself. It is a standard SaaS subscription application, and it does not require a Cloud Foundry or Kyma runtime to execute.
Because of this, SAP highly recommends provisioning the landscape portal in a completely separate, dedicated operational subaccount.
You want your central management plane physically isolated from your execution planes.
Exactly. And to even open the portal, your administrative user must be explicitly assigned the landscape portal admin role collection.
And assigning that role gives you access to what is undeniably the most financially impactful application in the entire BTP ecosystem, the Managed System Hibernation app.
Oh, this app is a lifesaver.
This app is the answer to the nightmare scenario I posed at the very beginning of the show. We talked about elastic scaling, bringing the application servers down to a minimum of 1 unit during idle times.
Right.
But here's the brutal reality. Even at 1 application unit, that massive ADA database and the persistence layer is still fully loaded in memory, and the cloud meter is still billing you by the hour.
And enterprise ADA in memory is incredibly expensive.
It is the largest line item on the BTP bill. The Hibernation app allows you to stop that meter.
It instructs the cloud orchestrator to elegantly shut down the ABAP application servers, flush the ADA memory to disk, and completely deallocate the physical compute resources.
Essentially putting the system to sleep.
Right.
So what does this all mean for the listener? It means massive cost optimization strategies. You can configure automated schedules in the portal. You can program your massive memory-heavy development systems to automatically hibernate at 7 p.m. on Friday and wake up at 6 a.m. on Monday.
You can hibernate test systems indefinitely until a QA cycle begins.
You can spin up a custom code analysis system, run a massive vulnerability scan, and schedule it to instantly hibernate the second the analysis log is generated.
The orchestration handles the wake-up sequences automatically. It is the single most effective way to protect your enterprise IT budget.
All right, I want to transition us into a quick knowledge check, a little interactive audio quiz to synthesize all of this.
Let's do it. Cement the learning.
Exactly. So for you listening, I am going to pose a question based on what we just discussed. I'll pause a beat, and then we will break down the answer. First question. What is the specific tool used to hibernate ABAP systems? Is it the administration launchpad or the landscape portal?
Well, the correct answer is the landscape portal.
Yeah.
The administration launchpad only looks at the internal health of one running system. It cannot deallocate hardware. You need the overarching landscape portal for that.
Perfect. Question 2. True or false, you must enable Cloud Foundry before your first use of the ABAP environment.
That is going to be true.
Done via the subaccount overview.
Exactly, because ABAP is cloud-enabled, not cloud-native. It physically runs as a service instance inside a Cloud Foundry space. You have to build the pious foundation first.
Awesome. Question 3. What must be set when creating an ABAP environment? I'll give you a hint. There are 3 key things from that JSON discussion.
The service plan, the email of the initial user,
Right, the add my mail.
and the system ID, or SAP system name.
And as a quick note, sometimes a quota plan is listed as a distractor in these exams.
Yeah, you define sizing through size of runtime, not a specific quota plan parameter in that JSON payload.
Question 4. Does Kyma use containerized apps?
Yes, absolutely. Kyma is a managed Kubernetes runtime, so its entire architecture is built around containerized microservices.
And final question. Which of these are cloud-native runtime environments? Cloud Foundry, Kyma, or ABAP?
Just Cloud Foundry and Kyma.
Right.
Remember, ABAP is cloud-enabled. It is adapting legacy architectures to the cloud, whereas CF and Kyma were born in the cloud.
Brilliant. So let us synthesize this entire architecture as we wrap up. Architecting a scalable, secure, and cost-efficient SAP landscape requires a deep mechanical understanding of 3 distinct environments.
You deploy Cloud Foundry as your broad pious foundation to orchestrate diverse applications and provide the underlying space for heavier instances.
You deploy Kyma as your heavily isolated modular Kubernetes powerhouse for massive containerized microservices that demand granular network control.
And you deploy the ABAP environment to bring your proprietary SAP extensions and decades of custom code safely into the cloud era.
It is a phenomenal architectural design. But as we finish this deep dive, I want to leave you, the listener, with a highly provocative thought regarding the future of this platform.
Oh, I like where this is going.
Think about the sheer volume of engineering effort we just discussed today. We are spending immense amounts of human capital manually configuring cloud Foundry spaces, agonizing over 1 GB differences in HANA entitlements.
Meticulously formatting JSON payloads to define array sizes.
Right, and building complex hibernation schedules just to manage the gap between our business code and the physical servers.
It is a massive operational tax on enterprise agility.
It really is. So look at the rapid advancement of artificial intelligence and autonomous infrastructure. How far away are we from a future where SAP BTP simply ingests the raw code you are trying to deploy, analyzes the processing requirements, and completely dissolves the concept of a human choosing a runtime environment?
That is a wild thought.
Imagine an autonomous BTP controller that could instantly weave together Kubernetes namespaces, spin up the exact ratio of HANA memory to ABAP compute units, dynamically shape the Istio service mesh, and orchestrate hibernation cycles minute by minute without a single line of human JSON configuration.
Will the rigid boundaries of Cloud Foundry versus Kyma even exist to the end user in 5 years?
Or will it just be one fluid, self-assembling execution engine?
It is a really compelling vision. I mean, as Kubernetes and AI orchestration become more deeply integrated into the hypervisor layer, the platform complexity will inevitably move from explicit manual configuration to implicit autonomous intent.
We are absolutely moving toward invisible infrastructure.
We really are.
Something to debate with your lead architects this week. But for today, your action items are firmly rooted in the manual reality of the present. Log into your BTP cockpit. Check how your environments are structurally represented in the tabs.
Audit your subaccounts, locate your kubeconfig.yaml files, and ensure they are locked down in a vault.
Please do that today. And most importantly, find your landscape portal and start aggressively scheduling hibernation downtimes to protect your budget.
Understand the mechanics, secure your endpoints, and optimize your runtimes.
Whether it is a desktop operating system or a globally distributed enterprise cloud, it all comes down to knowing exactly how the machine executes the code. Thanks for taking the deep dive with us.